Yep.
All right, well, let's just say I give you the equation 5x equals 3x plus 4. Is this perhaps something similar to what you saw in class?
Yeah, it looks somewhat similar.
Okay, so our number one goal here is to get all variables or get the variables on one side of the equation.
Okay, so you have to. Is it like like dividing?
We're going to divide at some point, but your typical first step is to add or subtract.
Okay.
Okay, so and generally you move everything left, so you move variables left. So in this case, you're going to subtract 3x from both sides of the equation.
Okay.
So on the left side, what is 5x minus 3x?
5x minus 3x.
Yes.
That is 2.
2x equals, and then this 4 just comes down. Okay, so you're asking about dividing. You do divide because you want x to be isolated. So you divide both sides by the number in front of x, which is
X equals 2.
X equals 2. Very good. Okay, so let's look at another example here. Okay, so let's say that I give you an equation 6x equals 3x plus 9. So again, in general, we want to move the variable left. So there's a 3x on the right side of the equation. We want to move that left, and you can do that by subtracting 3x from both sides.
Okay.
So that's 3x equals 9.
Okay. Wait. 3. We have to subtract by 3.
3x. You want to get all the x's on one side of the equation.
Okay, and that's and you have to multiply 3 times 9.
Well, no, we're not done yet. But when you get all the x's on one side, it's kind of like grouping. If you ever went out at Halloween candy, get all your certain candy together, or if you're organizing stuff, clothing, whatever, you're trying to consolidate all of the x's together. So that's why you move it left. Move left. Okay, so now this 3 is multiplying x.
Okay.
So how do you undo multiplication by 3? Divide by 3.
Divide by 3. Okay.
So x equals, in this case, 3. Okay.
Okay.
So do you have this example down? Because I want to have you do one on your own now, like this. I won't make it any more difficult. It'll be the same type of numbers, but
I think I'm getting it now. I think I'm getting it.
all right. So you try this one here. 7x equals 5x plus 8. So take 30 seconds, take 1 minute, see if you can work that out on your own, please.
Yeah. X equals 4.
Let's check that out. So you say x equals 4. So did you subtract 5x from both sides of the equation? You probably did. 2x equals 8. And then 2 is multiplying x. So you can divide both sides by 2. So yes, x equals 4.
Yeah.
Great. Okay, so now let's let's review some signs here. So let's say it's negative 2x equals negative 3x plus 5. So in general, you move everything left. You move the variable left. Now this on the right hand side is negative 3x. It's negative, which means that you undo it with addition. So this time we're going to add 3x. You add 3x
Okay.
because you want to undo the subtraction of the negative here. So it's whatever you need to do to undo the operation. So what is minus 2x plus 3x?
Minus 2x minus 3x.
You're adding plus 3x. So this is 1x. You've got negative 2, you've got positive 3. So it becomes just 1x equals 5. Now we could divide by 1 here, but does that change the answer at all?
No.
No. So you don't have to, but you could. Okay, so let's look at another example here. Let's go negative 2x equals negative 6x plus 20. Okay, so you're gonna undo this minus 6x, you're gonna move it to the other side of the equation. Yeah, so what do you add here? What should we add to both sides of the equation?
We add 6 and
6x.
6.
Yep, 6x, right? So on the left side, what is minus 2x plus 6x? Right, like you owed your friend
X equals 5.
Well, let's do this sequentially. Like I think you jumped to the final answer there. I want to make sure you
It's
understand.
4.
4x equals 20, and then you divide both sides by 4, so x equals 5. So it sounds like you're ready to do one on your own here. So let me have you do one without any help from me.
Yeah.
Negative 7x equals negative 10x plus 12. Let's give that a try, please. How are you doing on this one?
Yeah, I'm doing good. I'm just remembering.
Great.
X equals -4, where 10 it's just negative 7 minus 10, negative 10 minus 10.
What is your final answer?
4.
4. Okay. So we're going to add 10x to both sides. Hopefully you see that you add because there's a negative there.
Yeah.
So that's 3x, negative 7 plus 10x is 3x equals 12. And then you divide by 3 on both sides of the equation. So x definitely equals 4. Very good. Okay, so let's increase the difficulty just a little bit more here. Okay, so let's go 6x equals 8x minus, let's go 14 this time.
Okay.
So this time you want to move things left. That's just the general way to do it. Is 8x positive or negative?
It's a positive.
So you undo it with subtraction. You subtract 8x from both sides.
Okay.
So 6x minus 8x is negative 2x.
X equals negative 7.
So you're dividing both sides by negative 2 this time. So the negatives cancel out and make positive. This is positive 7.
Yeah. I thought it's going to be negative, but it's a 7.
It's always good to write out every step here to verify the final answer.
Okay.
So let's try another one here. Let's go 2x equals 7x minus 15.
Okay.
Okay, so we want to move the variable left. So that's just get in the habit of always doing that here. So you're going to sub 7x, subtract 7x from both sides. What is 2x minus 7x?
Five.
Negative 5x.
Yeah.
Okay, and that negative is important. It could be the difference between, left or right, up or down. Okay, and then what do you divide both sides by now?
The
I hear you wanting to
3.
say the final answer. Yes. Okay. So my concern though is I'm about to give you one that you're going to do on your own. My concern though is that will you follow the steps? Will you write out each step, or will you just try to give me the final answer? We will see. So let's go 4x equals 9x minus 25. Give this one a try, please.
Yeah. X equals 5.
All right, let me work it out here and see if I agree. It sounds pretty reasonable. Subtract 9x, subtract 9x, minus 5x equals minus 25. Divide both sides by minus 5. So x equals 5. Very good.
There
Okay,
we go.
so now we're just going to increase the difficulty a little bit more. We're going to start putting numbers on both sides of the equation. So we have numbers and letters on both sides of the equation.
Okay.
But it's the same process. Like you're gonna move the variables left. Okay, so do you see that you need to subtract 5x from both sides?
Yeah.
All I did was add a number here. So but
Oh, I think you have to subtract that, and then it'll give you a 2.
you're gonna get minus 2x minus 12, because this number just comes down, equals minus 8.
Yeah.
Okay, so now you're gonna add 12 to both sides. So this is that extra step. we
Oh,
didn't
is it like order of operations?
Well, we want to get the variable by itself. And the variable is not by itself currently. So negative 2x equals 4. Have you seen this in class or not?
Yeah, I saw that in class. I saw that.
Okay, so we divide by -2, divide by -2. I think there's a problem we should do before this. So let me just jump to another example here because I think this might be more helpful. Let's say you have 3x minus 7 equals -4. To solve this equation, do you see how the x is already on the left side of the equation?
Yeah.
So we don't have to do anything with the x, like it's good. But this -7 is in the way. How do we undo this -7? Add 7.
Yeah, you have to add 7.
Add 7 to both sides of the equation. This is 3x equals, what is -4 plus 7?
11.
But one's negative and one's positive. So it's
Three,
like you,
three, three, three,
it's
three,
positive 3, good. And then what do you divide both sides by?
3.
3. So x equals 1.
1.
Yep. Okay, so let's look at another one here. Let's go negative 2x plus 5 equals negative 15.
Okay.
Okay, we want to solve for x. We want to solve for x.
Yeah.
Okay. Notice the variable's already on the left side of the equation.
Mm-hmm.
So we don't need to move the x, but we need to move this number. How do you undo addition by 5?
You have to add a 5 on both sides.
If we add 5, do you see how it doesn't undo it? You have to do the opposite sign. What is the opposite sign here? It's
the opposite is negative.
So subtracted. Yeah. Okay, so that's negative 2x equals. Now this one, be careful here. Negative 15 minus 5. Negative 15 minus 5. What does that become?
10. Negative 10.
That would be true if this was plus 5. It's like you owe someone $15 and then you still owe them more money, $5. Now you owe them 20.
Okay.
And then you divide both sides by -2. So x equals.
I know. 10.
Okay, good. Okay, so let's have you try one on your own here, please.
Yeah.
Negative 4x minus 7 equals negative 23.
Mm-hmm.
See if you can work that out on your own, please. How are you doing on this one?
I'm doing it.
All right, that's great.
X equals 2.
X equals 2. Okay, let's take a look here. So I'm going to add 7 to both sides. The reason is that the x is already by itself. The x is already by itself. So on the right, what is minus 23 plus 7?
Minus 23 plus 7. Plus 7 is 30.
Yeah, but that would be true if it was positive 23. It's negative 23 plus 7.
Oh, 16.
Negative 16.
Negative 16. Okay.
Okay, now what are you going to do to get x by itself?
You have to get x with
What are you going to divide both sides by?
oh, you have to divide by a 4. 4. X equals 4.
Negative 4.
Yeah. Yeah.
Negative 4. So x does equal 4 because the negatives cancel and the
Negative
numbers are
4.
4.
Yeah.
Okay, so do you have this down in your notes, or do you want to take this down? We're going to do another example like this.
I'm just remembering to keep that in my mind.
Okay, well, I'm going to have you start doing a few more problems on your own here, so be ready to do that. Okay, so give this one a try, please, on your own. It's
Yeah.
very similar to the last one.
Yeah.
How are you doing on this one?
I'm just doing good. I'm doing good. I'm just remembering. X equals 9.
X equals 9. Okay, let's take a look here.
Yeah, yeah. It's because you have to subtract 8 on negative 35, and then it'll give you a 27, and then divide by 3, and then it will give you 9.
Well, everything you said, it does work out that way, but it is negative 3x, and you're adding 8 to both sides. Maybe you wrote that. I mean, obviously, I can't see what you're doing, but here you're dividing by negative 3. So x does equal 9. Very good.
Thank you. Thank you.
Okay, now let's go back to looking at some problems where you've got the variables on both sides and numbers on both sides. So let's say it's 1 plus 2x equals 3x minus 5. So do you see how there are variables on both sides of the equation?
Yeah, yeah.
Okay. So we want to deal with that, and we do that by moving it left. So you're going to subtract 3x from both sides of the equation.
Okay.
So on the left side, the number, whatever the number is, it just comes down. So this is 1 minus 1x equals negative 5. See how that number just comes down?
Yeah, yeah, yeah.
Okay. Now this one on the left here, is it positive or negative? The one I'm circling.
Positive, positive.
It's positive. So we undo positives with subtracting, subtract 1. This becomes negative 1x equals, what is minus 5 minus 1?
4 minus 4.
That would be true if this was plus 1, but it's not. You're subtracting 1. So you owe someone $5 and then you owe them another $1. How much do you owe them?
-6.
Negative 6. Okay. Now, this -1 here is multiplying x, so we can undo that by dividing by -1. What
Yeah.
is -6 divided by -1?
-6 divided by -1.
Yes.
It's 6.
Just 6. The negatives cancel. Very good. Okay, let's do another one here. -3x plus 4 equals -2x minus 9. So this time, again, just like last problem, you want to move the variable to the left. And you do that by undoing whatever math operation you see here. So if it's negative, you add. So you add 2x, add 2x. Okay, so question for you again is, what is -3x plus 2x? And if you don't like the money example, we can also just
5.
So -3x is like going three years back in time. And then from there, 2 plus 2 would be like going forward 2 years in time. Maybe that's a better analogy for you to understand. It is not 5.
Okay.
You went back 3 years in time. That's what negative means, but then you went forward 2 years in time. What does that become?
Okay, that right there is gonna be 1.
Well, that would mean you went forward in time, but you're going back 3 years in time. And then
Oh, you mean 5.
So you're going -3. Let's say today is 0. -3 means you went back 3 years in time.
Mm-hmm.
That's
Yeah,
-3.
yeah.
Plus 2 means you went forward 2 years in time.
Okay.
What is the result of that? Where are you?
I think you're at -1.
Yeah, -1, -1x.
Then okay, yeah. Thanks.
Okay, good. Now you got kind of this back to something you should know how to do. You've got this addition by 4. How do you undo addition by 4? How do you undo addition by 4?
Undo addition by 4, you just add 4.
Well, if that were true, this would work, but it doesn't, because you have to undo it with the opposite operation.
Operation.
Yes, you can't undo addition with itself. You have to undo it with its opposite operation.
Okay.
So how do you undo addition by 4? It's not add.
It's subtract.
It's subtract. That's right. You're going to subtract 4 from both sides. So on the left, it becomes -1x. And on the right, it becomes, what is -9 minus 4?
-9 minus 4.
They're both negative. So that means the answer has to be negative.
-5.
That would be true if this was positive 4. -9 means you're going back in time. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -4 means you're going even further back in time. 1, 2, 3, 4. So where did you end up? You went back 9 and then you went back 4.
That is okay. Yeah, that's okay. I got.
So what is it? What is -9
13?
minus? It's -13.
Yes.
Okay. Now, how do you undo -1 times x? How do you undo anything when you're multiplying?
You should divide by
-1. So x equals
-13.
Positive 13. Good. Okay, so let me have you try one on your own here. Look back and see, just double check here. Okay. All right. So we have -5x plus 5 equals -3x minus 7. So give that a try, please, on your own.
Yeah.
How are you doing on this one?
Yeah, I'm doing good. X equals -3.
X equals -3. I have no idea if that's right. We're just gonna work through it the way we've been doing it. We're gonna add 3x to both sides because you always move the variable left. So -2x, bring the 5 down. Now, this -7 comes down. So how do you
Okay.
undo addition by 5? What is the opposite operation?
Okay, so you must have to subtract by 5.
Very good. Now this on the left becomes -2x equals -5 minus 7. I'm sorry, -7 minus 5. Both negatives, the answer will be negative. But it's
Yeah.
minus 5.
Okay, that is 2, and you should add it.
I'm sorry, what is the number here?
Okay, that's 12.
It's -12.
And then it's x equals -6.
It's not -6. You are dividing both sides by negative.
Oh,
2.
wait, x equals 6.
Yes. Very good. Okay, so let's transition to a related topic. We kind of did this the other night. If I asked you if 3a equals 15, what is the value of a?
Matthew, your voice is echoing.
I apologize. If 3a equals 15,
Yeah,
what does a equal?
3 no, 5.
Very good. What is a plus a plus a equals 15?
That right there is 5 plus 5 plus 5.
Right, and this becomes 3a. So a is still 5. Not 15, 5. Good. Okay, now let me give you, I'm trying to work you through this here. Let's say a is 15. I keep doing that. A is 5, not 15. Let's say a is 5, okay? And I want you to find b plus a plus b, which equals 7.
Okay.
So do you see that you can substitute in for a? Now, what would you do from here? What's your next step?
The next step. All right,
Yes.
that right there, you should put.
Maybe subtract 5 from both sides?
Yeah.
Okay, so that's b plus b equals, what is 7 minus 5?
2.
2. And then b plus b is 2b.
Mm-hmm.
So what does b equal?
B equals 1.
Right. So far we have a equals 5 and b equals 1. So our last line of this problem is b times c plus c equals 4. So if
Okay.
b is 1, 1 times c plus c equals 4. What is 1 times c?
1 times C is 1.
1c plus 1c equals 4. If you have 1c here and another c here, how many c's do you have total? 2
Yeah.
c's.
You 2C, and then it can use the divide, and you should get 2.
Very good. Okay, so we're gonna do another one of these, but this time I'm gonna show you the whole thing at once.
Okay. Yeah.
But we're gonna do it step by step here. Okay, so here we go. We're stamping this in. Here's question number 2. First line says a plus a plus a equals 12.
Okay.
So try to, don't focus on any of this. Just focus on the first line there.
Yeah, that right there is 4 plus 4 plus 4.
That's right. Now I'm going to snip this in again. Now that we have our given information here. Okay. The second line. So let's just write the second line. You know, there's too much going on here. So you got to just cross those out. B plus B times 4 equals 5. Why did I put 4 there? Because A is
Supposed to be A needs to go to
A is 4.
Yeah.
Okay. So B times 4 is 4B. And how many B's do you have here? You have 1B here and then 4B here. How many B's do you have total?
How many B's? How many B's is 5 B's?
5 B's. So now you divide both sides by 5 and B equals
B equals 1.
very good. So we know that A is 4 and B is 1. Let's go to the last line here. Last line. Let me snip this in here. Okay, so we're going to this last line here. We know that A is 4 and B is 1. Last line says C plus B equals 5. What is the value of B?
4.
It is. Didn't we just spend the last?
Yeah, it's 4, and now you should C's are 1 and B is 4.
B is 1. It's written right here. B equals 1, B equals 1.
Yeah.
Right. So how many C's do you have on the left here?
2 C's.
2 C's plus 1 equals 5. So you can subtract 1 from both sides. And that gives you 2C equals 4.
Yeah.
So then you divide both sides by 2 and C equals
2.
very good. All right. Let's have you try, I'll have you just try this last one on your own. This may be our last question today.
Yeah.
So what I'd like you to do is when you're working through this, whenever you get a value, whenever you figure out what A is, tell me, or whatever you figure out what B is, I want you to tell me. That way I can check your answer along the way. All right, so look at that first line, just the first line, and tell me what A is.
Okay, so for that 1 plus 1 plus 1.
So A is 1. Very good. So use that information in line 2 now. B times A plus A equals 4. And you know that A is 1. So I want you to figure out the value of B.
Figure out the value of B.
Mhm.
Okay, so for that, that's 2 plus 1 plus 1.
This is multiplication though.
Oh, wait, what? Oh, well, okay. 1 times 2 plus 2.
But A is 1. You have to use that.
Oh, 1 times 2 is 2 and plus 2 is 4.
Well, what you said is true, but A has to be 1.
Okay.
So I get the feeling you're not writing anything down here.
I'm just remembering in my mind so I can remember for tomorrow.
Well, if you write it down, you will see that it is B times 1 plus 1.
Okay.
It's 4.
I'm just gonna be just putting it down and
So what is B times 1?
B times 1. It's
It's
1.
It's B. Any variable times 1 is itself. Okay.
Yeah.
So now you undo addition by 1 by subtracting by 1. So
Yeah,
B
and you
equals,
should 3, and you divide by 1, and then equals 3.
okay, so now we're down to our last letter here. B times C plus C equals 8.
So B equals 1. Is that right?
No, we just found that B is 3.
Okay. I think I know what you're. I think I know. I think I am getting it right now. I think I'm getting it. I'm gonna be doing this by my. I'm gonna be just focusing and just
Okay,
learning.
so 3 times C is 3C. If you have
Yeah.
3 C's here and 1 C here, how many C's do you have total?
4.
Okay, and then you divide by 2. So C equals 4. All right, well, ask your
Oh,
dad.
okay. There we go. Okay. I think there we go.
Ask your dad if he wants to chat. If not, I will see you next time.
Dad. Dad. Thank you, Matthew.
You're welcome.
I think I think I'm gonna understand now.
Hello, hi.
Hi, Dr. Kithari.
Hi.
So we worked on solving equations today. We started out with 1-step equations, and then we moved into 2-step equations, and then we moved into sort of systems-ish, but he did real well. I would like to see him take more notes if possible. And if he's got anything from class, I know I always say that, it really will increase his interest level in the lessons if we're doing stuff from his classroom. But he definitely got a lot of practice today. He got his math workout in. So I hope that he will remember some of this for tomorrow or next week when he's in class.
Okay. So this is from the classwork, right? Whatever that you did.
He did not provide any classwork.
Dad.
He did not provide any classwork, but he said that he was working on solving equations. And that's what we did for the bulk of the lesson here, solving 1-step and 2-step equations.
Okay.
But if you guys can text, email, whatever you want. I would definitely prefer to work on stuff that we know is in class as much as possible.
Okay. Okay. So at least is showing some interest, and he did some good, good work today,
Yeah.
right?
A lot of problems today. Yeah. So,
That's good.
all right. Well, I will see you guys next week. Thanks so much for scheduling, and have a great weekend.
Yeah, you too. Thank you.
Okay. Have a great weekend, Sourish.
Thank you.
Yeah. Bye.
Bye now.